Permutation and Combination, Part 2. Forming a different groups, or selections, from number of objects, is called a combination. Let's understand by an example. Suppose, we want to select 2 different balls, out of these given 5 given balls. Then, possible selections are: you can select either 1 and 2, or you can select 1 and 3, or you can select 1 and 4, or you can select 1 and 5, or you can select 2 and 1. No, you cannot make this selection, as selection 1 and 2, or 2 and 1, are the same combination, and has been already selected. Or, you can select 2 and 3. Or, you can select 2 and 4. Or, you can select 2 and 5. Or, you can select 3 and 1. No, you cannot make this selection, as selection 3 and 1, or 1 and 3, are the same combination, and has been already selected. On selecting 3 and 2, you cannot make this selection, as selection 3 and 2, or 2 and 3, are the same combination, and has been already selected. Or, you can select 3 and 4. Or, you can select 3 and 5. Or, you can select 4 and 1, no, you cannot make this selection, as selection 4 and 1, or 1 and 4, are the same combination, and has been already selected. On selecting 4 and 2, you cannot make this selection, as selection 4 and 2, or 2 and 4, are the same combination, and has been already selected. Similarly, on selecting 4 and 3, you cannot make this selection, as selection 4 and 3, or 3 and 4, are the same combination, and has been already selected. Or, you can select 4 and 5. So, there are total 6 ways in which 2 balls can be selected. And we have seen that, in this, order of selection does not matter. Means selecting 1 and 2 is same as selecting 2 and 1. Or we can say that there are 5 balls. From these 5 balls, number of groups of 2, or number of combination of 2 balls we can form, is calculated by 5c2, where 5 is the total balls, and 2 is the each of combination, or selection, contains balls, is equal to 5 factorial, divided by 2 factorial, into 5 minus 2 factorial. This gives total 10 ways. In general, we can say that the number of all combination of n things taken r at a time is ncr. That gives n factorial divided by r factorial into n minus r factorial. Let's see some special cases on combination problem. Number of selection of r things out of n things, if k things are always selected, is given by n minus k, c, r minus k. Let's understand by an example. If out of 11 football player, 6 are to invited into a party, such that captain and goalkeeper will always be invited. In how many ways this can be done? Solution: as captain and goalkeeper are always invited, so this can be done in 11 minus 2, c, 6 minus 2, that is equal to 11 minus 2 factorial, divided by 6 minus 2 factorial into 11 minus 6 minus 2 factorial. Let's see another special case. Number of selections of r things out of n thing, if k things are never be selected, is given by n minus k c r. Let's understand by an example. If out of 11 football player, 6 are to invited into a party, such that captain and goalkeeper will never invited. In how many ways this can be done? Solution: as captain and goalkeeper are never invited, so this can be done in 11 minus 2 c 6, which gives 11 minus 2 factorial divided by 6 factorial into 11 minus 2 minus 6 factorial. Another special case, number of selection of r things out of n identical things is equal to 1. Let's understand by an example. In how many ways 3 balls can be selected out of 5 identical balls? Solution: since all the 5 balls are identical, then number of ways to select 3 balls is equal to 1 way.